if we can manage a couple. All right. So remember how we left off on Monday talking about that a hormone is a chemical signal. It is a hormone because it gets released by some tissue into the blood. Okay, into the blood. Same thing can be called a neurotransmitter if it's not necessarily into the blood, but the action is going to be the same. Steroid hormones, okay, which is a certain type of hormone. All hormones bind to receptors to initiate their signal or their action in a cell. Where that receptor is going to differ. Steroid hormones, the receptor is usually inside the cell somewhere. It may be floating around in the cytoplasm, or it may be a receptor inside the nucleus. Steroid hormones are lipids. They're lipids. So it's very, very easy for them to pass through the cell membrane. Okay? They pass through the membrane, they bind to their receptor, and they cause something to happen. Generally, we think of steroid hormones, you guys are thinking of, right? You're thinking of testosterone, you're thinking of estrogen. That's great. But we'll see there's a couple of other steroid hormones, like cortisol. Okay? It's going to have some differing effects that are not anabolic. Okay? That's how steroid hormones. Peptide hormones, okay, which is the other class of hormone. Peptide hormones bind to a receptor on the cell membrane. So they're going to be in the blood, floating by, and then they're going to get bound onto the surface of a particular cell. Okay? So if we are thinking about the liver, where we have to break down glycogen, we're thinking about adipose tissue, where we have to break down adipose tissue, or we're thinking about muscle cells. Okay? The hormones are in the blood. The hormones are in the capillaries that supply blood to those particular tissues, and that's how we get where we're going to be. Okay? You do not have to know, although I love nothing better than a good signaling pathway, you do not have to know all of this shit down here on the bottom. Okay? I'm not going to ask you, insulin binds to its receptor, which activates a certain kind of G protein, which then signals through, right? Generally, it's adenylate cyclase and cyclic AMP, and we phosphorylate certain things and blah, 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 on down we go. We don't have to know that. All I want you to know is that peptide hormones bind to receptors on the cell surface. Okay? This will be important when we talk about the function of certain hormones. Okay? We'll talk about it. All right? Both kinds of hormones, though, initiate something. They tell the cell to do something. Okay? For the purposes of what happens during exercise, from a metabolic standpoint, generally what they're saying is break down glycogen so we have glucose available for metabolism. Break down adipose tissue or lipid tissue so we have free fatty acids for metabolism. Okay? After exercise, it is generally going to be take glucose into the cells to make glycogen back. Or, right, take protein molecules, amino acids into the cells to repair muscles or to try to make them grow. Okay? There's other things that will happen in other tissues, and we'll talk about those in the cardiovascular system and the pulmonary system in the next couple of weeks. Okay? I'm sure you guys have seen all of that before. Does that make sense? Okay. Typical endocrine. Okay. Typical endocrine. The hypothalamus, right? The brain is a very large endocrine organ. Thalamus, hypothalamus, pituitary, right? Anterior, posterior, pituitary. These are going to be things that release a lot of different hormones. We're not going to get into all of the releasing hormones and the things that are in the hypothalamus that then tell the pituitary to do certain things. Okay, we're just going to focus on a couple. But generally, the brain has several endocrine organs. The thyroid glands, which are here, right, kind of on either side of your throat, like all of this. Those are going to be very important. We have then the adrenal medulla and the adrenal cortex. Your adrenal glands sit on top of your kidneys. Okay, they sit on top of your kidneys. and they will release certain things. Certain things come from the medulla, certain things come from the cortex. We'll talk about that in the next coming slides. Your pancreas is a very big and very important metabolic endocrine organ. It releases insulin and it releases glucagon. Okay. And so it's going to play a huge role in helping us to control blood glucose levels. The kidneys themselves are also going to be an endocrine organ, especially when you talk about erythropoietin, okay, where we talk about things that are going to help us to control blood volume or the retention of water or sodium and things like that. And then, right, loosely they're called the gonads, but we mean ovaries, testes, okay, that are going to release testosterone and estrogen. Okay? We're not really going to talk about the effects of estrogen. We could have a whole course. We should probably have an entire course on the role of estrogen in exercise and sort of some of the interesting effects that it has. But we'll mention testosterone just very, very briefly in the context of that testosterone can also cause the breakdown of glycogen, the breakdown of fat, so that it's going to sort of play some metabolic roles in addition to what it does sort of anabolically after exercise. Okay. Debating how to do this. So how many of you have your assignment with you? How many of you have the chart? So if you're looking at me like, what? What is this chart you speak of? Okay. So the assignment, right? I gave you a chart and it's like, what's the hormone? What's the endocrine organ? Right? You guys remembering this now? So what I think we will do is we'll take about 10 minutes, okay? And I'll wander around and check in with you guys, but I want you all to share. Okay, if you already turned it in, great. If you have, you can just pull it back up and look at it, but share with your neighbors. And let's talk about what hormones you put on there, talk about what you think they did. What I want you to pay specific attention to, though, is what happens each hormone during exercise. You guys do that to kind of get primed, and then I'll come back and we'll walk our way through each one of those things. If some of you haven't done the assignment, now would be a good time. Okay? All right. Yeah. It's not all done, Zach. Too much anything. It's not enough of that. Okay. We're there yet? You're all like, we're gonna wait. We're gonna see what he says during class. We're gonna fill it in. No, for me, I have to. Like, we're gonna get it. It's because something that's yeah, oh, yes. Yes. Yeah, like it's. Thank you yeah, like they're permissive. Right, they're your friend that encourages you to do all the crazy things, right? We got this. Yes. Sure. No, it's a tricky balance, right? So the ideal thing would be to make it enough to be able to compare additional now. And then terribly whenever you get a space.
Yeah,
Just like practice. On raises. Everything but last. So get made. That's the hard. So I mean, all these things like, that's a silly challenge question. It will make it less. But it may not be best. Yeah. So I mean, carbonating is good. We think we'll get to that in very, very end today. Let's make your VO2 go up, but it helps you for the longer duration to regulate. Yes, sir.
I have those in one place.
It's more about like the percent change. Access. What you really need to know, the goal is just.
I guess it's one of the slides and this is good.
You can see why is it okay? That's a reasonable answer, right? It's not.
Okay, so
But then you gotta go, well, what? Insulin drives glucose into the cell. Don't we think we need glucose in our cells
guess if you look
to be able to run the body in the area? And yet you're saying insulin goes down. How the hell am I gonna get glucose? How am I gonna get this stuff for all of? No, it's sneaky. That's great. Y'all are gonna be very mad at the next semester. Now. I think by 10, people are ready to go by like 10. You planning to have coffee, ready to make food. So. Well, we're gonna wait.
I'm still everything like everything you got. I still do. That's so much. Okay. Yeah.
Guys, where are we going?
Yeah, we move our hands. They say it's
So your budget any type of. They can put during it. That's what it says.
Insulin sensitivity is.
So, one of the ways describing it is like.
So this is taking it in approach. You do it alone.
Right, it does not. Problem. I didn't even.
I don't know.
So eventually they normally do.
Okay, so insulin does decrease, yeah. Yeah.
That's the.
This shows that insulin is.
Answer that question.
So insulin is decreased.
So,
That makes sense.
so, no.
But
I don't. As soon as we understand that. Yeah, you're diabetes. So. A lot of money. Something. Some of it is all about just asking questions, and find stuff, and then they get them ready to shut it off. And back up.
Wait, just wait for so.
Not.
It's like the breakdown.
Right, somebody.
It is.
Yeah. Yeah. Well, go down this first thing, that's right.
I was saying.
That's right, that's not. Yes, based upon their. Only one chair. Follow. We'll see what happens. What's going on? Okay. You guys want to talk our way through some of this? Or do you want to keep working for a little while? Y'all would much prefer that I just give you the answers, right? Yes? Okay. How many of you, and I don't know how they did things, how many of you had Dr. Ketchum for human phys? Okay. She's still doing the entire like flipped classroom, like never lecture, just here's the stuff and then come in and do problems and things during class. She's teaching anatomy?
Yeah, I heard.
What happened to Cindy?
Like next semester, but.
Oh, okay. Let me see if we're on sabbatical. Pardon?
Yeah, I was about to say, I heard a while ago that she was like reaching out. I heard like Dr. That's it.
Okay. All right, so do you guys like the flipped classroom? It's a whole separate thing. Some of you are nodding your heads and saying yes. Some of you are like, no, it's terrible. Did you feel like you were never taught anything?
Yes.
Okay.
Yeah.
If I told you that educational research says that's a vastly superior way to get people to learn and remember things, would that surprise you?
No, this is repetition.
Right, but you guys having to struggle through means you'll remember it. But it's never like we do not educate in that way. And so it really throws people for a loop because since you were like yay big, all that's ever happened is, it's just like, you tell me what it is and I write it down and I memorize it and then I give it back to you on a test in that particular way. So it's a really fascinating kind of way of doing things. So in my very first job, I was at a teaching institution. They paid us to go to seminars to learn how to teach and do things in that way. And then we would try it in class and like everybody would freak out and not like it and complain that we weren't teaching and doing those things. So anyway, this just makes me think, like, but this isn't in the slides. How do I know what the answer to this is? If you haven't told me yet. And my snarky, sassy 8:30 in the morning self says, well, think about it. Figure it out. Google it. Get on ChatGPT. Anyway, so we'll talk our way through. We'll see what you guys think and how you did. Okay. All right. So let's start with this. Let's start back at the very big picture. Okay. Because that will keep everything and all of the hormonal responses, I hope, in context. Okay? In context. What are the goals as it relates to blood glucose during exercise? What are our goals as it relates to blood glucose all the time?
Keep constant.
Constant. Okay? Constant. Why? Why must we have constant blood glucose?
So that way we can have our brain still function.
That's right. Our brain needs it to function. You guys heard of a phenomenon called hypoglycemia? If people become hypoglycemic, the next thing that happens is coma. Because the brain says we don't have enough blood glucose, shut everything else down to stop using the glucose so we can have some. Okay? So, goal number one at all times is to keep blood glucose constant. Okay? That's number one. Now, our second goal, if possible, and this is related to fatigue, if possible, is to do what with muscle glycogen? Break it down. Sometimes I will break it down so that I don't use blood glucose. That's good. But if I break down too much, I also fatigue. Okay? So over time during exercise, our other goal, and Bernie's running 12 miles, I'm not going to ask you how fast that was, right? It'll probably make me very, very unhappy.
You would probably hate 4 of those ones.
I would hate 4 of those miles. I would hate all 12 of them. Okay. So I mean, what? Like, we talking like 5-minute pace, 5.5-minute pace? How high? What?
For those, for almost.
Should you do it another an hour?
We did like, yeah, we did like sub 4, like 5-minute pace.
Okay. It's cool. Good for you guys. Good for y'all. Okay. When muscle glycogen is depleted, also fatigue. So one of the other goals over time during exercise is to try to not use up all of our muscle glycogen. So we want to maintain blood glucose, that prevents fatigue. We want to hold on to what we call spare muscle glycogen, that prevents fatigue. Okay. And so then to do all of that, one of the other primary things is, how do we not use glucose and not use glycogen for energy? We need to use fat. Very good. Okay. So think of what the hormones are doing in that context. Okay. We need to maintain blood glucose. We need to eventually spare glycogen, and we're going to try to do that by increasing fat use. Okay? So just keep those broad goals in mind, and hopefully in that context, what happens to the hormones based upon what their function is should make some sense. Okay? All right. Let's start with one that's actually not that important during exercise, but is wildly important outside of exercise. And that's insulin. You guys have all heard of insulin, right? Okay. Insulin comes from the islets of Langerhans in the beta cells in the pancreas. Great, wonderful, we know all of that. Okay. Insulin is a peptide hormone. The pancreas releases it into the blood in response to an increase in blood glucose, which normally happens when? When does your blood glucose go up? After you eat a meal that has some carbs in it. Okay. My breakfast this morning was a candy bar. Yep, it was. Okay. We were in a hurry. We ran out of things to eat at the house. Ellis was yelling at me about making her some pancakes. I made her pancakes. I didn't make myself any little pancakes. And anyway, so I had to stop when I got gas and I got a candy bar because I'm truly an adult, right? And I can do whatever I want. Plasma glucose goes up. Okay, you release insulin. The goal of insulin then is to bind to a receptor, it's a peptide hormone, bind to a receptor on tissues that have insulin receptors, which are primarily muscle and fat. Okay, primarily muscle and fat. Insulin binds to its receptor, and its function then is to pull glucose out of the blood into those cells. In muscle, it does it in this particular way. It binds to this receptor, and then there's this giant signaling, what we call a signaling cascade, signal, 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 and the eventual response is to bring a glucose receptor called GLUT4. This is wildly important, okay? To bring GLUT4 from inside the cell to the membrane of that cell. Okay? Insulin binds, we translocate GLUT4 to the muscle membrane. That GLUT4 then starts grabbing glucose in the blood that's flowing by that muscle cell. As it brings them in, and GLUT4 is going to pull itself back out of the membrane, back into the cell, right? We lower blood glucose, and then GLUT4 stays down in there and waits for the next insulin response. Okay? That's how we do this to regulate blood glucose. As glucose levels in the blood fall, that shuts down the pancreas, and we stop making insulin. Okay? One of the things that insulin also does as it drives glucose in is it promotes glycogen synthesis. It tells the cells to make glycogen. It activates an enzyme called glycogen synthase. Okay? Called glycogen synthase. So in the context of this, what do you guys think should happen to insulin during exercise?
Guys,
Why? Why would you want it suppressed? Don't we want glucose to go into our cells so that we can use it during exercise? Doesn't that seem like a useful thing? It needs to go, the glucose needs to go in the bloodstream. Okay, so we don't want it in our cells. Okay, we want to promote glycolysis. We don't want to make, but are we breaking glycogen down during exercise? Wouldn't it be good to then try to make it back? Now I'm just being a pain in the ass. Right?
What, feel like,
How am I going to get glucose into my cells? I'm going to use some. I need to get some in there. How am I going to do that? Okay. So you guys are right. Okay. What happens to insulin during exercise is vas activus. You would think it should go up because you want to be able to get some energy, get some substrate into your cells. But it doesn't have to go up. Okay. If insulin increased during exercise, every one of us would be in a coma within 20 minutes. Okay. We would all be hypoglycemic within 20 minutes. Okay. It would be wildly dangerous. And this is why anybody knows someone, or maybe anybody knows someone that's a type 1 diabetic? Okay. This is why insulin, that we have to be really careful exercising type 1 diabetes. If they don't have a continuous glucose monitor, if they don't have an insulin pump, okay, then if they take insulin and then they go to exercise, it can be really, really dangerous. Because insulin drives GLUT4 to the membrane to bring glucose into cells. So does exercise, all by itself. Okay. Muscle contractions evoke something that's over here in red called the insulin-like effect of exercise. All I gotta do, right? Couple of squats. And in my quads, I have simulated this exact same pathway with no insulin. Okay. Contracting skeletal muscle drives GLUT4 to the membrane and helps us bring glucose into cells. So if you did that and then you add insulin on top of it, you're going to pull too much glucose in. Way too much glucose in. Okay. Now you may be asking, well, how does exercise do that? The answer is we don't know. We've been trying to figure it out for 60 years. NIH has been funding it for 60 years. We will eventually figure it out, and that person will win a Nobel Prize. It will be one of the single greatest scientific discoveries ever, because we'll be able to cure diabetes once we figure that out. Okay. We have some ideas of what's going on, but we don't know for sure. The insulin-like effect of exercise is also why, if you are reasonably active for all of your life, you will not be a type 2 diabetic. It is why if you are a type 2 diabetic, we can mostly treat it with physical activity, because we can even all of this stuff out. Okay. After exercise, after muscle contractions, as we'll see later, to replenish glycogen, you actually make more insulin receptors. And so you become more sensitive to insulin after a bout of exercise for a couple of days. And that's why exercise is so good for protecting. Okay, all right, so that's insulin. You guys got all of that one? Its importance during exercise is what? Okay, fair. But in today, right now, if I'm gonna exercise right now, is insulin important for me exercising? Yeah. No, right? The answer is very simply is no. It needs to go down. If it doesn't go down, we're really gonna be in trouble. Okay? So that's kind of a tricky one. What about glucagon? Sometimes called the anti-insulin. Okay? Glucagon also comes from the pancreas, it comes from the alpha cells. It's also a peptide hormone, but it gets released when blood glucose is low. It's low. So if blood glucose is low, what do we think a hormone should do when blood glucose is low? Right, it's going to try to increase blood glucose. Where is it going to get more glucose to go into the blood to raise it? Glycogen stores in the liver. Okay. Also, blood glucose is low. Let's break down some adipose tissue so we can have something else to break. Something else to use as a substrate. And that is, in many, many ways, exactly what glucagon does. It promotes glycogen breakdown. It promotes the breakdown of adipose tissue so we can put fat or lipids into the bloodstream. It also promotes gluconeogenesis in the liver. So it has big effects in the liver. Let's try to make some more glucose. Let's try to break down glycogen to get glucose, to keep blood glucose up. Okay. Any of you guys who have not had breakfast, you have high glucagon right now, or you did earlier at least. Okay. No breakfast, higher glucagon. Otherwise, your blood glucose will fall. Okay. So from that instance, given that's what it does, what do you guys think happens to glucagon during exercise? It definitely increases. And why is that important?
In order to keep our blood, the levels of our blood and, or our glucose, of our blood glucose up.
Correct. It helps to keep blood glucose levels up. It helps to provide fat so that eventually we can try to spare glycogen by using fat. Okay. What I just showed you guys is about to be a theme. Okay. Glucagon does this. Guess what almost every other hormone that we're going to talk about also does during exercise? These exact same things. Okay. Promotes glycogen breakdown, promotes the breakdown of fat. Okay. Those are going to be and they're going to increase during exercise. Those are kind of the big things. Thyroid hormones are a little bit different. Okay. Again, you don't have to know what exactly T3 and T4 are, or kind of what it is that are the base parts of those hormones, but they come from your thyroid gland. Thyroid hormone in your thyroid gland plays a huge role in regulating metabolism. Okay, if I give you a shot of T3 and T4, your metabolic rate goes up like immediately. You get real jittery. Okay, it's kind of like being whacked out on too many Red Bulls. Okay. We had a participant in one of our research studies came in the other day, and we had forgotten to tell that participant that they could not have any caffeine for 8 hours before they came in because we're going to have them exercise. And caffeine was going to do things, and they had a lot of caffeine. They were real hyped up. And they're like, you got to go home.
What's a lot of caffeine?
What's a lot? Like, I don't know, like 500 milligrams?
Which equals what?
That's probably like 3 or 4 espresso shots. Right? There's about 80 milligrams in a regular 8 or 10 ounce Red Bull. There's about 150 to 200 in 8 ounces of black coffee, depending upon sort of where the beans have come from. Right? So yeah.
So in other words,
there's about 100 or 120 espresso shots, depending upon kind of again where it's from. So it's a lot.
So in other words, they're more hyper than your kid.
Yes. Every time my dad comes to town, he gets coffee and threatens he's going to give coffee to Ellis. And we're like, oh, dear God. Like, if you give Ellis coffee, like, we're just going to leave for 2 days. Just, y'all are on your own, grandparents. So, of all the people that don't need an upper, it is not my child. So, Okay. She got very upset last night because she wanted ice cream. And I told her that we were in the car so she could have a milkshake instead of ice cream. And she threw a huge fit and was very pissed at me because she wanted an ice cream cone to have in the car with sprinkles. It was very key. Daddy, I want an ice cream cone with sprinkles. I was like, we're in the car, we got to drive away to home, like it's going to make a mess. We're going to get you a milkshake. And she did not really understand, right? Because you're 5, that the milkshake is just ice cream.
Yeah.
It's just soft ice cream, basically. Once she got it, she was very pleased. And she was like, what is this whipped cream? And I'm like, yeah, I know, it's good stuff. And then she said to me, because she's smart, and she said, well, Daddy, the last time we got ice cream, you had an ice cream cone in the car. She was like, you had a cone, and it was we go to Brahms, and I get like the swirl, like the soft serve stuff. She's like, you had a twist cone. You get to have an ice cream cone in the car. Why don't I get to have one? I was like, fair. And I couldn't tell her, like, because I'm not going to spill it everywhere on all of that. So anyway, she's way too smart for her own
I
good.
was about to say, outsmarted by your kid.
I'm outsmarted by a 5-year-old. So anyway, I was late to get her. We had to scramble to get to gymnastics. She didn't get food beforehand. When she gets hypoglycemic, she's real freaking fussy. Just like her mom.
In other words, she's angry.
Anyway, I got lost in something. Thyroid hormones, they regulate metabolism. They're really, really important for regulating weight, and those kinds of things. But what thyroid hormone does for other hormones and things that are in exercise is what we call permissive. Okay. It encourages or assists and promotes the function of other hormones. Okay. Right. It's the one that helps things out in that particular way. We see lots of stuff with people that are both hyper and hypothyroid. Our cat is hyperthyroid. It's very strange. Not quite enough that we have to give the cat something to suppress all of that, but because of all of that, she pees all the time, like just all the time, because it ramps up sort of kidney function and those things. We had a dog when I was little that was hypothyroid. So we had to give him things. Poor guy got real chunky because of all that, because it was metabolism like slowed down. So it wasn't just that he was an old lad who weighed 110 pounds and was giant, this big giant fluffy guy in those ways. So very common kinds of things. Okay. Let's talk about epi and norepi. You guys have heard about this before, right? Epinephrine is adrenaline. It's the same thing. We're going to call them epi and norepi. While they often have slightly different functions, mostly driven by that certain tissues have slightly different densities of receptors for epinephrine and norepinephrine. Okay. Functionally, they both tend to do the same thing. They're going to come in this instance from a blood glucose standpoint. They're coming from the adrenal medulla. Okay. They're in the brain. Some of these things we can talk about them being neurotransmitters, but hormonally, they are coming from the adrenal medulla. If I give you epinephrine and norepinephrine, this is fight or flight. This is, right, increased metabolic rate, increased glycogen breakdown, increased fat mobilization, increased heart rate, increased contraction force of the heart, make cardiac output go up, increased blood pressure, increased breathing rate and depth. This is the velociraptor is here. Oh shit. Right? This is fight or flight.
You watched Jurassic Park, didn't you?
You know. No, I heard somebody was talking about that on a podcast I was listening to. So that was where I got that this morning. So anyway. So that's the thing. All right. They make everything go up. So guess what happens to epi and norepi during exercise? It increases. These two tend to increase in direct proportion to exercise intensity. Okay? Intensity. If I had Anna stand up and sprint around the room. You want to do that, Anna? No? Okay. We have her sprint around the room, right? Versus asking someone else to just walk. We're going to get a much higher epi and norepi response when you sprint. Okay? Massive increases in these things when you do very, very high intensity exercise. Because one of the things that it does, in addition, right, to breaking down glycogen and mobilizing fat, is they need this acute effect on heart rate and cardiac output. So they've got to go up really, really fast. Okay? So they're going to go up during exercise, and they're going to help us kind of facilitate making metabolic substrates available, but also controlling what's happening. Okay. Cortisol. How many of you think or have heard on social media or something that cortisol is bad for you? Prolonged exposure is bad for you, right? You're all stressed out college students, right? Alex, like, no, I'm not stressed, not at all. You're like, whatever, we got like 3 weeks until graduation, like we're not stressed anymore.
This is the one thing I'm gonna say.
Okay. Cortisol is good. Anybody ever had a cortisone injection? Anybody ever taken prednisone? You have some kind of an infection or something, right? No? Or when you have like, they typically will give it if you've got like a sinus infection or something.
Okay, maybe.
Cortisone suppresses immune function. Okay? So in that way, it can be good. It can be very effective in that way. It comes from the adrenal cortex. It's a steroid hormone, but it also has effects on metabolism. Cortisol is wildly, wildly important for regulating blood glucose in between meals. Okay? In between meals. So if you're stressed and you're intermittently fasting, you're going to have a lot of cortisol. Okay? And the little secret is it's not that bad for us. It's really not that bad for us in a lot of ways. Okay? But what it does is it helps us maintain plasma glucose. So it breaks down glycogen in between meals. It actually increases protein breakdown. That's one thing that could be bad. So it causes catabolism. Break down protein. So we have amino acids available for gluconeogenesis in the liver. Okay? It increases the mobilization of fat, and then it also really functions to blunt inflammation. Okay? To blunt inflammation. My most favorite times every year in baseball was when I would get my yearly cortisone shot in my shoulder. I have impingement in my shoulder. If you guys want to feel stuff, you can come up and you can do this, and you can feel the head of my humerus hitting my acromion process. When I turn like this, right? When I pronate, you can feel it grinding around in there. Super fun. I get a cortisone shot every year. You just feel awesome, right? You just feel great because it blunts all the inflammation. It knocks out a whole bunch of things. But that's what's going to happen, okay? So cortisol does a weird thing during exercise. It rises initially during exercise. And then after about 30 or 45 minutes to an hour, it's going to fall, okay? Why does it fall? I don't know, because the other hormones have kind of taken over, okay? But initially, during a bout of exercise, cortisol goes up, okay? And it's the same reason for everything else. It's going to try to maintain plasma glucose. It's going to break down liver glycogen, and then it's going to stimulate mobilization of fat, okay? And that's why that's going to be reasonably important. Hopefully you guys have seen by now, you guys know the word redundancy? You know what a redundancy is?
Like,
Over and over and over, okay. Do we call it something else? Pardon? Repetitive, okay.
safety measure.
A safety measure, a backup plan, right? In this kind of way, all right? Notice how we have multiple hormones that are all doing the same thing, right? That's a redundancy, okay? We have multiple redundancy plans from a hormone standpoint to help us break down glycogen, break down adipose tissue, so we can try to supply energy to cells during exercise.
So during exercise, other than while maintaining like glucose level, does it like help, I guess, kind of what like that initial inflammation that we're feeling first?
No inflammation during bout exercise.
But why does it rise initially in exercise?
To help us from a mobilizing glycogen, keeping blood glucose, and to break down fat. Most inflammation that you experience from exercise is the day after. It's the day after. Okay? It usually takes somewhere between 12 to 24 hours to initiate an immune response. That's why by the time you're actually sick, you got exposed to things like multiple days beforehand. Because it takes a little while for the immune response to kind of get jazzed up. That's why like my legs are a little bit sore. They're sore from running on Monday, which is also a sad thing about my life. But, okay, I ran all of a mile very slowly on Monday and my quads are sore. But I'm sore today. I was a little bit yesterday, but I'm more today because it takes 24 to 48 hours for the immune response to kick up. Okay. And he's like, what?
No.
What sort of
no,
bro science have
no.
they been telling you guys?
No, that sounds about right, because my legs are still feeling
Yep.
Monday's weight room.
Okay, you guys can tell how old I am because of the pictures that I put on here. I just haven't changed some of my slides. It's gonna be here. Let's talk about growth hormone. Oh, I'm sorry, Nick.
Why do we use cortisol to blood inflammation when the body produces inflammation as a response to damage?
Great question. An age-old debate. Sometimes too much inflammation can be a bad thing, right? Or if you have chronic inflammation that is preventing you from participating in the sport, doing some kind of activity, right? You guys see all the things on TV now for rheumatoid arthritis, like watching any of the NCAA basketball games or any of those things, the men's tournament, the women's tournament, any of those things. You'll see stuff about that. You'll see advertisements for things that treat, it's the same drug, but they use it to treat like Crohn's disease and eczema, or whatever it is, the kind of plaque, those things. They're all autoimmune things. It's overactive immune system that causes things. So we can give something like cortisol, we can give an immunosuppressant to try to counteract the negative effects that it may be having on those kinds of things. That's what anybody take Advil? Yeah? Okay. So it's an anti-inflammatory, right? There is a level of debate. And we have some scientific evidence that when my legs are sore, I have muscle damage, that if I take the Advil, I won't, but others will, that's about 50-50, that I may feel less soreness within a couple of hours if I take Advil, okay? But we know that if we track a person that's had muscle damage like that over like a month, if you take a lot of non-steroidal anti-inflammatories early on, it actually takes you longer to recover in the long term. You feel better today, but it will take another extra week or something before you're fully back to 100%. So there's this sort of push and pull of, I need to feel better now so I can participate in whatever my sport or activity is versus what are kind of the long-term consequences for it. So it's fascinating. Okay, Brittany.
I was gonna ask if that was due to decrease kidney function.
It's not about kidney function. It's actually something about that we need the long-term effects of the immune response to help us repair tissue correctly. And if we blunt it early on, it will take it a little bit longer to do things. Okay, growth hormone from the anterior pituitary. We've already talked a little bit about its anabolic effects, but it exerts some of those anabolic effects by increasing amino acid transport. Okay, it drives protein synthesis, but it also, this is the real reason that the bros take growth hormone, is it increases fat mobilization from adipose tissue. Okay, it blunts insulin action, which is kind of weird, but it increases fat mobilization. The big thing if you're taking steroids, when you take growth hormone, is it helps you lean out in some ways. The testosterone makes you big. The growth hormone helps make you lose fat and be leaner in addition to some other things. Okay, growth hormone increases during exercise. The thing here on the left, I didn't look today to see a thing, but you can get on Amazon and purportedly buy some growth hormone if you want. It's probably not really growth hormone. Or maybe it is, and it's coming from, I don't know, Russia or Kazakhstan or someplace where it's not regulated in that way. Most people know about pituitary changes in growth hormone, pituitary dwarfism, and giantism. Overproduce growth hormone, be really, really tall. Underproduce it, and people are what we would call a dwarf. They're very short in those ways. Normal, otherwise, it's all just about growth hormone levels. Okay.
Most of us have a certain amount. It goes up and down during sort of development and those kinds of things as we're going to go. But during exercise, growth hormone increases. I haven't put it on here, but so does testosterone. It does basically the same thing. Breaks down fat, breaks down glycogen, helps to provide substrate and things during exercise. Okay. So here are our goals. I got a bunch of these kinds of things. Graphs that are going to show sort of what's gonna happen. Okay. I want to demonstrate this last little thing, and then we'll get you guys out of here for today. On the left, it's showing the weird cortisol response, right? Cortisol goes up and it goes down. The red shows free fatty acids. The big thing, right? We want to keep blood glucose constant. That's good. We do that by breaking down liver glycogen. But the other big thing that happens during long-term exercise that's really, really important for maintaining glucose and for not using up all of our muscle glycogen is denoted by the red line. It's the increase in blood levels of free fatty acids as exercise progresses. Okay, so that's over 3 hours of exercise, and there's almost a 4-fold increase in blood levels of free fatty acids. Okay, just about every hormone that goes up during exercise, one of its functions is to break down adipose tissue. If there is fat in the blood that is available, we will burn more fat for fuel, which means we don't have to use glucose or glucose from glycogen. Okay? So that's one of the big things that helps us over time with exercise, right? And you can see this graph is just laying over the top of it, right? Free fatty acids are in blue, but it's laying over the top of that. Growth hormone and epi and norepi, but really it's epinephrine, norepinephrine, glucagon, cortisol, and growth hormone all lead to the breakdown of adipose tissue. Okay, they all lead to the breakdown. Now you may be asking yourself, well, is this why when I exercise, am I going to be able to shift around body composition and lose fat? The partial answer is maybe, but a lot of times is free fatty acids go way up, and then if you don't use them during that bout of exercise, they're just going to get synthesized back into adipose tissue to some extent. Right.
Why does that, because I'm looking at all the charts and epinephrine, norepinephrine increase like kind of a little more linearly, and then bulk fast drops down, and then.
Sorry, here's your epi and norepi. They're going straight up, right? Very, very linearly.
Yeah.
Why are the other ones not that linear?
Well, just really only growth hormone. Why is it like kind of a smaller slope, and then all of a sudden it like goes like way up?
So that's a function of the data that were used for that particular chart. Those are data from a study where they measured all of them together.
Okay.
There's other data that don't look exactly like that. It's a little bit more sort of linear in those ways. All of that. Okay. Lily.
Would you go over the thyroid hormones importance to exercise?
Would someone like to help Lily out? Why is thyroid hormone important? Bring down adipose tissue. Good thought. Probably not quite right.
Important for
Why is thyroid hormone important for exercise? What does thyroid hormone really do? It regulates metabolism.
It encourages and assists other hormones.
Right. And it helps the other hormones exert their effects, which then probably does then the other hormones lead to breakdown in adipose tissue. So we're close. I'm being pushing. Okay. Okay. Very, very, let me see what else I have at the very, very end here. Do I have the glycogen stuff? No. Let's talk really, really quickly about fluid balance. Okay. So we talked about osmotic and hydrostatic pressure a little bit when we talked about the pump. I exercise, metabolism goes up, it drives fluid into the muscles. They look bigger and it's all just water. Okay. Well, that's the thing that happens with fluid during exercise. Sweating is the other big thing. We need to regulate body temperature. We exercise, core body temperature goes up. If you don't sweat, you'll cook yourself and die. Super fun.
exercise is actually wildly dangerous, right? You guys remember that, or anybody had tested the prescription, y'all already tested the prescription? Y'all talk about the increase in cardiovascular event risk during exercise, right? Like ladies, y'all are basically never gonna have a heart attack during exercise, like one in every like 950,000 exercise events, right? Guys, we're like one in, well, y'all, and not us. So y'all are like one in every like 400 or 500,000 events. You to be my age, it's like one in every 10. Right? Yeah, I know, it's great. You know, it's super awesome. Okay? But you exercise. If you never exercise, it's bad for you, but you don't ever have a risk of having a heart attack during a bout of exercise. It's a weird thing. You also sweat during exercise, or if you don't sweat, or exercise when it's hot, you can cook yourself. So hypoglycemia, right? Hypothermia, like exercise is not great. We need to understand then that these things happen and change where water and fluid is from the plasma in our blood and into our muscles and in our cells during exercise. During exercise, plasma volume, partially because of sweating, also partially because of this driving fluid into cells from the metabolic processes, plasma volume can fall 5–10%, sometimes more than that. You sweat a whole lot, okay? That has consequences of dehydration, consequences for overheating or hypothermia, and all of those things also decrease cardiovascular function. Makes heart rate go up, it makes stroke volume go down, okay? And it limits our ability to increase cardiac output. So there's bad things that can happen because of this. So after exercise, one of the things that we do is we're going to try to use some hormones to help regulate and make sure that we get body water back where it needs to be, particularly in plasma, particularly water in the blood, okay? So there are two big hormones that help us with this. One comes from the adrenal cortex, it's called aldosterone. The other one comes from the posterior pituitary, it's called antidiuretic hormone, okay? And their functions are opposite of each other, but they end up causing the same thing to happen, okay? Aldosterone leads to increased resorption of sodium in the kidneys. Okay, we're not going to get into all of the things about renal function, and I always forget where exactly the sodium retention takes place. Is it in the distal convoluted tubules or someplace else? But if the kidneys retain sodium, as that sodium stays, it holds some water. Okay, so retain sodium, we retain body water, that keeps plasma volume elevated. Antidiuretic hormone, rather than messing with sodium, it actually holds on to and makes water retention at the kidneys. But it functionally does the same thing. If we retain more water, then we also retain more sodium. And if we retain more water, then we keep plasma volume up and keep body water up. Okay? So the combination of these two things helps us, after a bout of exercise, to actually increase the plasma volume, the amount of water in our blood, for a couple of days after a bout of exercise. When we get into aerobic training in a couple of weeks, you guys will see that one of the primary things that helps to make VO2 max go up with exercise training is driven by these two things. When you do aerobic exercise, you retain water, it expands your plasma volume, your blood volume goes up because plasma volume goes up. When blood volume goes up, it makes stroke volume go up. When stroke volume goes up, it makes cardiac output go up. When cardiac output goes up, VO2 max goes up. It's very, very simple. Okay. So we need proper function of these two things. Okay. When you drink too much water, you can kill yourself, right? You guys know that? Yeah. You drink so much water that, right, we cannot keep up from an aldosterone standpoint to be able to increase enough sodium. And so it's called hyponatremia, that can be an issue. Okay, so these two things tend to get released not during exercise, but mostly after. They're mostly not gonna have wild effects during exercise, they're gonna exert effects after. Okay. All right. Question? Hey, yes, I was just gonna talk about it. Perfect. Okay, I am moving the exam from next Wednesday to the Wednesday after. So from the 10th to I believe it's from the 10th until the 17th. Or is it the 11th until the 8th? One of those things. It's currently supposed to be next Wednesday. We're gonna move it to the Wednesday after.
So the 17th.
The 17th. Okay, I will change that on Canvas today. I will change it today. All right. Any other questions, any other comments? Okay.
We have had some.
I need your assignment, either written or you can turn it in on Canvas, please. Okay? Have a good weekend, we'll see you.